Sai Ram. Welcome to this segment of the study of structural isomers of this coordination compounds. We have already seen what is isomerism. Isomerism is that phenomena where you are able to have same molecular formula but different structures, or say same molecular and structure formula but different spatial arrangement. Now, that spatial arrangement concept was discussed in the stereoisomerism in part 4, whereas this part 5 we will discuss with the structural isomerism that are possible. So, what is structural isomerism in the first place? It is those compounds having same molecular formula, but they differ in the structures of these compounds which are there. And there are 4 types in this. One is linkage isomerism, coordination isomerism, ionization isomerism and solvate isomerism. What are these? What are the definitions of this? That let us see at a later stage. But first, in general, let us understand this minimum concept of isomerism. So, we are able to see around 8 compounds here. They have different molecular formula or different structural formula as such. Let me take the first 2 set of compounds. Now, you are able to see that in both these compounds there are 2 cobalts, 5 amine, 2 chlorides, and then there is NO2 which has been present here, and along with this ONO. So, in this part which is there, here this is dependent on the structural change that has been seen with the linkage. So, let us see the first isomerism which is there, which is nothing but linkage isomerism. So, what is this linkage isomerism? Is that it is that type of isomerism where the isomers are coordinated with the presence of the attach of different type of ligand atoms which are present. So, if you see in this examples here, we are able to see that NO2 and ONO which are being attached, here the attach of ligand is by nitrogen, whereas here it is by oxygen. So, how do we define this isomerism? Is compounds having same molecular formula, but they differ in the attachment of the atom to the central metal ion. The central metal ion here is cobalt, whereas the atom here is nitrogen, whereas here it is oxygen. Similarly, let us come across the other set of compounds, which is having cobalt and chromium as central metal ion, amine and CN. Both these compounds have same number of molecules of particular atoms, but what you see here is that in the first example, cobalt is attached with amine, chromium is attached with cyanide. In the second example, chromium is attached with amine and cobalt is attached with CN. So, what do we see here is same molecular formula, but they differ in the attachment of the ligands with the central metal ion, or there is an interchange of attach of ligands with the central metal ion. In the third set, we are able to see that once again there are same molecular formulas. What is differing is who is ionizing outside is differing. Now, in this case, this will be one positive part, Br minus is the negative part. Whereas in this case, this is the positive part, whereas SO4 2 minus, because this is how it splits out. So, if I have to just show you the splitting of this compound, it is going to be present like this, Br2 plus. While this compound splits like this, giving SO4 2 minus ion, this compound will rather give you a Br minus ion. So, those compounds which are having same molecular formula, but the ions that they give out will be different. This is another type of isomerism. And how can we name this isomerism? We can name this as ionization isomerism, because ions that are generated differ in these cases. What about the last one then? This seems to be similar to this, where in this case you are able to get 3 Cl minus ions separately, whereas in this case you are able to get 2 Cl minus ions because Cl2 is outside, and you are also able to get 1 water molecule. What has happened here is 1 Cl has gone inside. From this example, 1 Cl has gone inside as secondary valency and water has come out, one of the water molecules. So, this is named as solvate isomerism. Why it is named as solvate is because water can be used as a very good solvent. So, what is the role of water here? Here water is acting like a ligand, all the 6 water molecules. Whereas here 5 molecules are acting as ligand, one of the water molecule is acting like a water of crystallization, or just the water molecule is simply attached to the coordination complex which is present here. So this is why this is called a solvate isomerism, but it is almost similar to ionization isomerisms which we are able to see. So just to revise all these parts here, to know these different sets of compounds which are there, the first one which is seen here can be analyzed as attachment by different ligands, where this we call it as linkage isomerism. In example, you are able to see that nitrogen is attached in the first case, whereas in the second case it is actually oxygen which is attached. So definition, the isomerism exhibited by compounds which differ in the attachment of the ambidentate ligand. What are ambidentate ligands? Those ligands which have more than one center of donation. The second type of isomerism which we are able to see here is coordination isomerism, because in this coordination isomerism, in the first example you are able to see amine attached to cobalt, cyanide attached to chromium, whereas the same molecular formula, but the change is amine is attached to chromium, whereas Cn minus is attached to cobalt. The third set of isomerism, which was linkage isomerism, what is happening here is when I try to ionize these compounds, we are able to get different ions. In the first case I got Br minus, second case I got SO42 minus. The type of isomerism caused by interchange of ligands with the counter ions. Basically to say that the counter ions which are given out are different in this case. The fourth type of structural isomerism, solvate isomerism, which is basically the solvent molecules are acting either as a ligand or they are merely present as free solvent molecules. In this example, water is present as ligand in the first case, where all the 6 molecules of water are ligand. In the second case, 5 molecules of water are ligand along with 1 chlorine, whereas one more molecule of water is simply present as a solvent molecule. So this is about the study of the structural isomerisms that are present in these coordination compounds. Thank you. Sai Ram.